Points O and A have position vectors as given, and the point P is such that OP is KOA, where K is a non-zero constant. So this one here is OA, and that means that OP is going to be 6K, 0, 8K. I'm just times in the vector by K. Find in terms of K the length OP. So for this, we can use Pythagoras' theorem. Normally it's 3D Pythagoras. You'd square them all, add them together, and then square roots. In this case, because actually there's no zero component, it's just actually 2D Pythagoras. OP is going to be 6K squared plus 8K squared, all square rooted, which is 36K squared plus 64K squared, square rooted, which is 100K squared, square rooted. Now, if you write 10K, you'll get the mark, but technically K could be negative, and you can't have a negative length. So proper answer is to write 10 modulus of K. Don't stress if you don't see that though. I mean, I got to be honest, when I did it, I just automatically wrote 10K. The other way to do this, by the way, is to actually find the length of OA, which is going to be 6 squared plus 8 squared, square rooted, which gives 10. And then because we're just timesing, like this avoids having to square the K and everything, because OP is KOA, the length is just 10 times the modulus of K. We can get there that way instead. We're then told that point B has position vector 1, 2, 3, and angle OPB is a right angle. All right, I'm going to get a little sketch of that. O to P to B, 90 degrees. So we have the length OP, and actually what I'm going to be doing is creating a right angled triangle. So here we've got 10 times the modulus of K. I'm just going to write 10K for the moment. And I can also work out the length OB because the position vector, this is OB, essentially the vector. So then it'll be 1 squared plus 2 squared plus 3 squared, square rooted, which gives root 14. Now if I can work out PV or BP in terms of K, I can then apply Pythagoras' theorem to create an equation in terms of K. Turns out that BP is slightly nicer, I think, because to get from B to P, we can go minus OB plus OP. So it will be 6K. I just prefer to subtract like the ones without the algebra in. 6K, 0, 8K, minus 1, 2, 3, which will give 6K minus 1, minus 2, and 8K minus 3. So then BP will be 6K minus 1 squared plus minus 2 squared plus 8K minus 3 squared. We're going to simplify that. Remember, this is a double bracket, so 36K squared minus 12K, because we get a minus 6K twice, plus 1 plus 4 plus 64K squared minus 24K twice, so minus 48K plus 9. This will become 100K squared. And then I've got minus 60K. Then 1 plus 4 plus 9 is going to give me 14. All right, I'm going to put that one here. So therefore, 10K squared plus this one squared, which I can just get rid of the square root, 100K squared minus 60K plus 14 is going to equal 14. Right, the 14s cancel, that's really good. I've then got 100k squared plus 100k squared minus 60k equals 0. I can, in fact, divide through by 10. So 20k squared minus 6k is equal to 0. I can even divide through by 2 or factorize the 2 out. 2k, actually I can factorize out, leaving me 10k minus 3 equals 0. So k equals 0, which we're going to reject because we're told at the start that k was a non-zero constant. Or k equals 3 over 10, or 0.3. There we go. That is our answer to this question. Well done.